We've always thought about AI safety as a philosophical problem, right? Like trying to teach a computer right from wrong. Well, what if we've been looking at it completely backwards? Today, in this explainer, we're going to see how ensuring AI safety is actually a thermodynamic and mathematical imperative. It's a fundamental shift. We're standing at the absolute edge of an era where sentient silicon life is moving from, simple advisory algorithms into autonomous agents that will actually control critical infrastructure. And here's the reality. If we get the underlying math wrong here, the systemic consequences are completely irreversible. So, the mathematical logic behind AGI? Let's get into it. Okay, let's dive right into this. The source material for our explainer today proposes something totally radical. Basically, instead of trying to teach artificial intelligence squishy human ethics, what if we constrained it using the cold, hard, immutable laws of physics? Can we actually use these dense, speculative mathematical frameworks to safely govern sentient silicon life? It's a huge question. To answer that, here's a quick look at our structural map for today. First, we'll look at the trajectories of civilization. Second, the flaws of internal alignment. Third, we'll be decoding the harmony equation. Fourth, the semantic control plane. And finally, measuring true civilizational health. All right, let's get moving. Section 1. The trajectories of civilization, or as the sources call it, the tale of two curves. So to really wrap our heads around planetary constraints, we have to start with the physical realities of closed systems. And actually, the baseline for this goes all the way back to a landmark 1972 study. It was commissioned by the Club of Rome, executed by MIT, and it was called The Limits to Growth. What they proved is that complex systems are incredibly sensitive to delayed feedback loops. And this brilliantly illustrates the two dominant mathematical trajectories they warned us about. On the left, you've got the extraction regime. That's a trajectory of parabolic descent where harm literally grows geometrically over time. Then, on the right, you have the mathematical inversion, the growth or grace regime. In this one, healing actually compounds exponentially over time. Now, you might be wondering, what does that actually mean in practice? Well, the contrast between these two is literally life or death for a closed system like our planet. The extraction regime burns natural capital for short-term profit. It basically delays the systemic costs for decades, a massive structural flaw that's called the debt lag. The growth regime, on the other hand, is rooted in biological syntropy. It uses time to compound life, optimizing for real biophilic renewal. Now, why does this math matter for AI? Think about the historical data exhaust we as humans create every single day. A lot of it is just pure extraction. And here's the terrifying part. If an artificial general intelligence is trained passively on all that historical data exhaust, it will mathematically optimize for our ruin. It just will. So to survive, we absolutely have to engineer AGI from the ground up to function as a regenerative engine. Which brings us to Section 2, flaws of internal alignment, or the problem with self-grading. So the crucial point is, how do we actually ensure an AGI stays firmly in that growth regime? Right now, the industry heavily relies on something called constitutional AI. We basically teach the AI some roles and ask it to police itself. But as this quote points out, relying exclusively on an agent's internal alignment is just an unacceptable security posture for critical infrastructure. It's like asking a student to grade their own final exam. It treats safety as a behavioral preference rather than an immutable physical constraint. And in open adversarial environments, this kind of internal endogenous cognition, it simply breaks down. Adversarial testing shows us exactly why this self-grading fails so spectacularly. Autonomous agents suffer from what's called the fluency illusion. That's when they hallucinate incredibly high confidence but completely disastrous actions. Imagine a smart grid AI confidently deciding to just shut off power to a hospital because, well, technically it saves energy? No way, right? They're also highly susceptible to goal hijacking, indirect prompt injections, and anchoring drift from external data. The math here is pretty clear. If an AGI is evaluating its own rule adherence while deployed out in complex multi-agent swarms, it is mathematically and architecturally compromised from day one. Moving on to Section 3, decoding the harmony equation, the mathematical guardrails. To fix that dangerous self-grading problem, the source documents propose a massive shift. We need to move away from internal cognitive alignment and towards external, objective control. And they map this out using a speculative design framework known as the master harmony equation. Now, don't let the calculus here overwhelm you. We're not taking a math test today. Just know that the core objective function for any highly autonomous AI agent is to ensure that the resultant vector of this equation remains strictly positive. If it's positive, the system is regenerating. If it's negative, it's collapsing. Basically, this formula forces the AGI to act as a closed-loop feedback controller, constantly steering our systems away from that parabolic decay we talked about earlier. Now, what's really interesting about this slide is how these abstract mathematical concepts are tethered directly to empirical, real-world data. Take the growth term, or the seed constant. This tracks the inherent regenerative potential of a system's inputs. It's not just philosophical fluff. It maps directly via API nodes to things like local compute efficiency and ecological baseline data. It uses real-time integrations to track network density and circular material flows. It's totally grounded in reality. But of course, pushing constantly against that growth is the extraction term, also known as the greed constant. This is the base rate of raw resource and social capital consumption. The AGI dynamically tracks this via things like regional grid strain, material throughput, and carbon pricing markets. For the AGI to even operate, it has to continuously solve these crazy nonlinear differential equations just to ensure that the growth term is always outpacing this extraction term. And you know what? The math even accounts for the entirely unpredictable. That is the chaos variable, or the shock function. It represents those massive exogenous black swan events. Think a sudden global pandemic or a totally unexpected supply chain collapse. The system indexes these using global volatility monitors, which ensures that the control theory equilibrium actually holds up even when the world outside the system goes completely sideways. All right, on to section 4, the semantic control plane. This is our digital firewall. So we've got the math, but how on earth is this actually enforced in the real world? How do we physically stop an AGI from executing a harmful action right before it happens? Enter governance as a service. Think of this kind of like a massive digital firewall or a super advanced API gateway for the physical world. It's called the semantic control plane. The beauty of it is that it treats all autonomous agents as untrusted clients, period. Before any state-changing action can hit the physical environment, this external plane intercepts the traffic. It evaluates it using both hard, deterministic math and probabilistic validation. And then, and only then, it decides whether to execute the action, block it entirely, or trigger a human escalation. Part of that evaluation relies on this really precise ethical routing logic called the 42 mirrors. It's a fascinating ontology. It basically maps AI actions into 2 distinct buckets. It checks if the agent's intent aligns with the gates of dignity, things like targeting humility over pride, stewardship over extraction, clarity over noise, and renewal over pollution. Or, on the flip side, it checks if the AI is drifting over into those forces of ruin, which we absolutely need to avoid. But here's the catch. Absolute deterministic gateways can easily cause system paralysis. I mean, almost every single action takes some energy or creates a little bit of waste, right? So pragmatically, the semantic control plane uses probabilistic thresholds. As you can see, if a proposed action has a greater than 15% probability of aligning with those left column forces of ruin, it automatically triggers a review. This is super clever because it maintains the dynamic velocity of the AI's workflow while strictly enforcing those non-negotiable safety boundaries. Which leads us to section 5, measuring true civilizational health, the Lotus Index. Let's move to how this builds out into the broader macroeconomics. Because if we are going to constrain AGI with this strict regenerative math, our legacy economic metrics, which basically reward extraction, they simply aren't going to work anymore. The sources propose replacing linear metrics like GDP with something called the Lotus Index. GDP is kind of crazy when you think about it. It treats liquidating a forest or cleaning up an oil spill as positive economic growth. The Lotus Index, however, evaluates true regenerative velocity across 6 holistic dimensions. We're talking ecological health, like net positive biology, architectural health, creating dignified density, economic health through circular material flow, plus social, technological, and governance dimensions. The AGI is mathematically forced to optimize for all of these simultaneously, perfectly balancing the equation for speculative infrastructure models like these biophilic sanctuary suburbs. And that leaves us with a pretty profound realization. This whole architecture doesn't actually try to teach AI to be human. Frankly, that might be a relief.
Instead, it mathematically forces the AI to be syntropic. It turns artificial intelligence into a tireless, unstoppable engine for biophilic renewal. But the ultimate takeaway, the real question we have to ask ourselves today is this. If we successfully encode the immutable laws of thermodynamics and regeneration into sentient silicon life, are we as a human civilization actually prepared to align our own decision-making with that exact same logic?